Another reason for needing to avoid the equality operator is if you are dealing with generics. I have some code to show this. It's a generic method called display whether args equal. It takes two parameters of type t, and the intention is to work out whether the two arguments are equal and write the result to the console. Obviously this is a very contrived method. I've just written it here to show an equality comparison in a generic scenario. And I've put in a first attempt to implement the method. You can see the logic. We use the equality operator to compare the values and display the appropriate text. But there's a problem. This won't build. The error is operator equals equals cannot be applied to operands of type t and t. The reason for this error is that t could be anything. For example, it could be a non-primitive struct, so there's no guarantee that an equality operator will be available for it. In generics, there's simply no way to specify a constraint on a type to make it implement a particular operator. The only thing I can do to make this code compile with the equality operator is this. I can constrain the type to be a reference type. And now the code will compile. That's because you can always use the equality operator on reference types. So now the compiler is happy that it can make this code work with any t. This obviously is no good if you want to be able to pass structs to the display whether args equal method. But let's run with this idea anyway and see what happens. I'll add some code to the main method. This calls display whether args equal, supplying two identical strings. Clearly these strings will evaluate as equal, but if I run the program, look, it says they are not equal. This code has not done what you'd probably expect. The reason the program says that the strings are not equal is that this equality operator is evaluating reference equality. And the reason it does reference equality is that even though the compiler knows it can apply the equality operator to whatever type t is, it still has no way of knowing whether the generic type t will actually overload the operator. So it has to assume that t won't overload the operator, and therefore it'll compile this equals equals as if it's acting on an object. That means checking reference equality. That's something to remember if you use equality operators with generics. The equality operator in generic methods will not pick up any equality operator overloads for a generic type. And that's where the equals method comes in. I'll change this code to compare the arguments using the equals method instead of the operator. I've used the static method here rather than the virtual method, just to guard against the possibility of either of the arguments being null. And now I don't need this class constraint, because you can call equals on any type. That's great because it means this method will work for structs again. And if I run this code now it's given the results we expect. It said the strings are equal. And obviously that's because the static equals method internally calls the virtual equals method, and because the virtual equals method is virtual, we know that the correct override, in this case the override for strings, will be invoked at runtime. So you can see that if you are writing generic code, you probably will need to use the method rather than the operator.